Okay, now that you've probably already watched the video on doing linear regression, because that was listed first, let's walk through some of the ways of manually solving the problems we're going to be asked to do on the first assessment. So I'm going to start working through from the beginning the other practice problems for Math 121 Intermediate Algebra Practice Test 1. So here we have our practice test. You can download it from Canvas or pick it up from in class. Let's red's a little bit bright. So let's go with the blue. So put our name at the top. Okay. Right, so it's readable and such. So the first thing we do is as we see problems, we try to pick out numbers and equations. So here's an equation. Let p be the function defined by p of x equals 40 minus 2x, where x represent years, so that's important. P of x represents population of people. Okay. Then we're asked to determine the value of P6. So 6 is 6 years later. What's the population going to be? So P6, whatever's in the parentheses goes in for the x. So then we get 40 minus 2, replace the x with the parentheses, and in that parentheses is going to go the input. So that's 2 times 6. And then gives us 12. 40 minus 12 gives us 30, 28. And 28 what? 28,000 people. Notice our units are in thousands. So we might write that down. 28,000 people. Now find the value of x at which p of x equals 18. This is the other thing. 18 is an output. It's outside. And so it's going to replace the p of x. And so for that one, we get the 18 over here. And then we get the rest of the equation on the other side. 40 minus 2x. We have not replaced x. X is still x. We are solving for x. And so what we do is then we work through the rest of this to solve for x. So we want to get x by itself. First thing we do is subtract 40 from both sides. On the right hand side, the positive 40 and the negative 40 become 0, canceling out. 18 minus 40, so opposite signs we will subtract. 18 from 40 is 20, that's 30, take away 22. Sometimes hard to do it. The 40 is negative, it's the larger number, so 22 is negative. And that's equal to 2x. The next step is to go ahead and divide both sides by 2. So we divide by 2 on the right side, means we divide by 2 on the left side, actually a negative 2, I'm sorry, sometimes I do this. See, there was a negative here, there needs to be a negative on here, so we need to divide by negative 2. On the right side, negative 2 divided by negative 2 cancels, leaving us with just 1x. And on the left side, 22 divided by 2 is 11, negative and negative make a positive. So 11 is our answer. X equals 11. So maybe if you want to directly answer it over here, x equals 11. 11 equals x is the same thing. So after 11 years, we're down to 18,000 people. What is the slope? Well, the slope is the number in front of the x. The slope is negative 2. And what does it mean? The population is decreasing. By 2,000 people per year. So you use the units from the slope. The units, notice the x value is years, that's the bottom of the fraction. The years, the population of people in 1,000, 2,000 people per year. I suppose I should have put 2,000 people, but we're talking about population, so that's okay. Okay, so far so good, I hope. Let's go back to green. If the given is a function, so first, is this a function or not? So we've got an input of 2, 4, 6, and 7. No repeated inputs, so it's guaranteed to be a function. Each input has its own output. So if the function, determine if the given is a function, okay, yes, it's a function. And then the domain and the range of each of the following. So give myself a little bit more room. I'm going to put that over here. Domain is simply listing all of the x values. So that's going to be 2, 4, 6, and 7. That's our domain, all the x values. The range is all the y values, and if there's a repeated y value, I don't have to list it again. But so I've got 5, 5, I only have to list that once. There's a 5. And we should put it in order from smallest to largest, but if we don't, it's not necessarily wrong. It just might look different. That's okay, different's good. We need diversity, we need variety, and that's it. That's our domain, that's our range. Okay, so that's the first part. I'm going to clear off the screen. Remember, this is a video. You can pause it at this point, take a look at it as long as you want, or move forward. So let's give ourselves some more working space here. We'll clear that out, and we'll go on to the next set of questions. Same thing in here. Is it a function? So the B part, the following graph. Is it a function? And if so, get the domain and range. Okay, so this is a graphical look, domain and range. Okay, so is it a function? The function's determined by the vertical line test. So if we draw vertical lines everywhere, do they go through the graph at more than one place? And vertical lines are not so vertical anymore, but you get the idea. We just kind of go through, and each vertical line's only going to touch the graph in one place. So yes, it is a function. It has passed the vertical line test. Let's clear that out. Function. Now, as far as domain and range, the domain, what we want to do is we come from the left, and we till we first hit the graph, and that x value that we first hit is going to be our domain. Let's do our domain in green, just to be different. So we come along, coming from here, there's nothing, nothing, and then we hit a point. It's a solid point, so this is sort of like drawing a box. Draw a straight line. So what's the x value? It's -2. And it's included. So domain is going to start at -2. And then I keep going. I've got graph, so I'm in the domain until where's the end of the domain? When I get to this point here, this x value, and I'll just, there it is. That's the end of the domain. What is the x value? It's 4. So I go all the way to 4. It's a solid dot, so that means it's included. So I'll indicate it this way. This is called interval notation. If I was asked to do inequality notation, I could list it as -2 less than or equal to x less than or equal to 4. Inequality. Okay. We'll do the same thing with the range, but let's make the range, how about violet? Now the range is the y value, so we come from the bottom and then we stop at the top. So we come up in the first place we hit. It's easier to draw horizontal lines is here. So notice we're boxing in the graph. That looks to me like a -9. That's when we first hit the graph. Since it's not an open circle, it's assumed to be a closed circle. It's not a point listed there. We keep going until we get to the very top of the graph, which is the top point up here. So we'll go across like that, and we look at its y value, which is 7. So the range goes from -9 all the way to 7. It's a solid dot, so it's closed in. And then with inequality notation, we would list it as -9 less than or equal to, they don't give us a calling on this, so we'll just call it y. It's not x, it's y. It's the range. That's how inequality notation, you're actually able to tell which one's domain and range by what's in the middle, x or y. Notice interval notation, you just from looking at the notation itself, if it's not labeled, you can't tell which one's domain, which one's range, so you've got to be sure to label it. So that's that question. Just draw the box around it. The left and right boundaries, that form the domain. The range is formed by the bottom to the top boundary lines. Okay, this next one looks like we're going to need some extra space, so I'm going to clear this off. Again, you can take a look at this as long as you want. You can freeze the video, pause it, or move on. So we're going to give us some more space here. We'll just keep scrolling through this. Okay, you rent a car that has a base fee of $100 and costs $75 a day. So the two important numbers, $100 and then $75 per day. That's the changing amount, a base fee, and then a changing amount. This is going to go with the variable. Write a verbal statement that describes how the total cost of your rental is to be determined. Well, we're going to pay $100 when we first rent it. It's a base fee. And then for each day, we're going to pay $75. So our cost is going to be equal to the $100 we paid as a base fee, a one-time fee, plus each day we're going to pay $75. And we could say maybe D if you want. They didn't tell us what variables to use. If you want a verbal, they want a verbal statement. I would go to the equation. Verbal statement is the cost will be $100 plus $75 per day. So notice we really almost just copied down what was already there. Then they want us to what is the input and the output variable? The input is how many days we rent it for, which is a time function. Time in days. We'll put the units and what it is. The output is simply going to be the cost. How much did it cost us in dollars? Write the verbal statement in part A as an equation. Well, let x represent the input variable, let c of x equal, or c, your choice, represent the output variable. So we've actually already did that first, and that's what I find a lot of students will jump to that first instead of the verbal statement. C of x, or the c, cost is equal to 100 plus $75 per day, which we're going to put in as x. In the context of this problem, what does the statement C of 4 equal 400 mean? Well, again, taking it as we go, the 4 is days, the 400 is dollars. So if we rent for 4 days, our cost will be, or is, I guess this is shorter, $400. There we go. Okay, I think that takes care of this one. So let's, again, clear it off and keep moving. That's that. This one we've done, we did a lot of it. We didn't necessarily do all of it. Or did we do this? Maybe we didn't. Okay, I don't think we did, but this is a good one to explain and use our linear regression, hopefully, that we've gotten down from the previous one. Okay, so determine the average rate of change or the amount of fuel consumed per passenger car from 1960 to 1970. Finding the slope from 1960 to 1970. Okay, maybe we'll do this one by hand. We could do it either way. 1960 is the input, the output is 668. I'll put that there. 1970 is the other one, and 760. So we subtract the bottom from the top. 1970 from 1960 is negative 10 years. And 668 minus 760 is going to be 92. Let's verify that with the calculator. Sometimes I do it backwards. It's always 668 minus 760, 92. Okay, so we're back here. Negative 92. And then we take the x divided into the y, change of the y. So that's going to give us a negative, make it positive. 9.2 divided by 10, or 92 divided by 10 gives us 9.2. And what is this? This is gallons per year, gallons consumed per year, per car, gallons per car per year. Gallons Okay. Determine the average rate of change of the amount of fuel consumed per passenger car from 80 to 95. So then, in that case, let's change colors here. Go with the green. We're looking at the point 1980 and the other data value for 1995. We'll do the same thing. If we get exactly the same, that's going to lean us towards thinking that it's a linear function. If not, it wouldn't be linear. So again, we do the same thing. Let's put 1995 on top. And in the bottom, let's go with 1980. So we subtract the years and we get 15. We subtract these. Oh, this is going to give us negative. We actually went down. That's 46. So it's 46. And then we take 15 divided into 46. And we're going to get negative 3 point something. Let's come back over here. I think the calculator is nice. 46. So negative 46 divided by 15 gives us 3.0666, so 3.07. Let's go with that. And again, same units, gallons per car per year. Gallons per car per year. Okay. Is it linear? I would say no. In my explanation, different slopes. Oops. Different slopes. So if any of the 2 points have different slopes, it's not going to be linear. And not only are they different, one's a positive slope, one's a negative. So it was increasing and then it comes down, it's decreasing on part of it. So definitely not linear. All right, let's just keep plugging away. Actually, this one's again going to be a longer one. So let's clear off the screen and then scroll down a little bit. We'll just kind of keep solving these problems here as we go. And this is what we'll be working on in class as well. You have plenty of opportunities to work through these. Let's go with back to blue. We're given a linear equation. 2x plus 3y equals 12, so we were asked to solve it for y. Okay, so what we're going to do is, I guess the first part we'll do over here, write it out, 2x plus 3y equals 12. We will then subtract 2x from both sides, because our goal is to get the y by itself. On the left-hand side, the 2x and the negative 2x cancel. That's 0. We're left with 3y. On the right-hand side, we have 12 minus 2x. Those are not like terms, so we can't combine them. Our next step will be to get the y by itself. Since we're multiplying by 3, we divide by 3. And on the other side, we're going to distribute the 3 to both parts, so divide both by 3. Cancels out. We get y equals 4 minus 2/3 x. So that's the equation right there. Find the slope of the line. Well, we just found it. It's negative 2/3. It's the number in front of the x. That's the beauty of having it in slope-intercept form. Use the axis below to draw a graph of the equation. Okay, so what we have is we have a y-intercept. Let's come here. Let's do this in green. Our y-intercept is 4. So that means that 1, 2, 3, 4, we have a point right here. Put a nice big point. 0, 4. X is 0, y is 4. Then what we're going to do is we're going to use the slope. It's got a rise over run. The rise is -2. The run is 3. So that means from this point we rise -2, which means we go down. Then we go over 3. 1, 2, 3, and we get another point. If we would have went up, we could have gone back 3. So another way to do it is to go up 2, 1, 2, and then back 3, 1, 2, 3 would be about here. And we can see we've got, all these 3 points are on the same line, and something like that. Okay, label the axes. Here's x, here's y, and there's about 1, 2, 3 I said. So that's good enough. Does a point -2, 5 lie on it? So here's -1, -2, 5 would be just above the 4. -2, 5 looks like about there. It doesn't appear to be. Maybe I didn't draw it very good. A quick way to check is that we could plug in these 2 points and see if the equation equals. We could do it either in the one we came up with for the answer, or we could go back to the original. I think the original probably is easier to work with. So we're going to go 2x, remember keep that open, plus 3y with an open parentheses is supposed to be equal to 12. And then what we do is we plug in the x and the y. The x goes in for x, the y goes in for y, and we see if we end up with 12. So we get -2 here, we get 5 there, -2 and -2, that'll give us a -4. Sorry, +2 times -2, and here we get a 15. And the question is, does -4 plus 15 equal 12? It's close, but not quite, right? 11 equals 12, so therefore it does not equal 12, not on the line. So, from our graph itself, it looked like it could be, but it was close enough. I was wondering maybe if I made a little error in my drawing, I might be off. So I checked it with the equation. That's the 2 options we have. A point has to satisfy the equation and to be on the line, and if it's on the line, it will satisfy the equation. So those are the 2 things that have to happen. Let's see, what time is it? 11:30. I got to get going here pretty quick, so we'll bust out a few more, and then I'll get on my way, and we'll do some in class. Okay, so that's that. Let's see. We did this one on the regression. I think we talked about all of it. Okay, so now let's do these ones here. Let's go back to green. Okay. So we're given that we have a line, equation of a line that has a slope of 2 and goes through this point, 1, -4. Every equation of a line can be represented as y equals mx plus b. M is the slope, b is the y-intercept. So we've got the slope. So that's nice. We've got y equals 2x plus some value b. We were not given that value, the y-intercept. It's not -4 because this 0.1 negative 4 is not the y-intercept. It does not have an x value 0. So our next step is we have to get rid of 2 of these variables. We cannot solve an equation with 3 variables. So what we do is we take our 0.1 negative 4, we plug the x value in for x, and the y value, we plug that in for y. Okay, so then we're going to have negative 4 equals 2 times 1 plus b. And now we can solve it for b. Okay, negative 4, 2 times 1 is 2. And then to get b by itself, we simply subtract 2 from both sides. So we get that b at 0 is negative 6. Both are negative, so we add them together. It takes the sign of the larger number. And so to write the equation, because that's what was asked for, we're not done yet. Y equals 2x minus 6. There's our answer. Now this one, determine the slope. We actually did that with the regression calculator, but I'll show you another method. We can basically subtract one point from another. You could also use the slope formula, but there's plenty of examples of that. So I'm going to take 11, negative 3, put that on top, and then I'm going to take 7, 13, put that on the bottom. You could do it the other way if you want, either way you want to do it. We're going to subtract the bottom point from the top point. So 11 minus 7 is 4, positive 4. Negative 3 minus 13, that's going to be more negative. That's actually going to be 16, and it's going to be negative. We take the 4, tuck it underneath the 6, divide. Negative 16 divided by 4 is negative 4. And hopefully I think that's the answer we came up with the graphing calculator. So we can do a double check on that. So a manual way of finding slope and a technological way given in the previous video. Okay, this is one. A couple of them. I kind of get can get people these multiple choice ones. Some people think they're easy, and maybe they are if you really understand what you're doing. But there's always one question that sort of seems like it's right, but it's just not. So you got to be careful with these. So the first question we're given again, instead of reading the whole thing, I go to the number part. We've got some relationship. 81 is the input, 75 is the output. So and we're asked to explain what that means. Well, to explain what that means, I need to figure out what input is and what output. And I can kind of come here, S of H. This is going to help me because it's got the H as the input. So now I kind of look around. Where's it? Oh, here's an H. What is H? It's the number of hours you study. So 81 hours studied. I'm going to write that there because that's what it means. 81 hours studied. That's a lot. For a quiz in one of your classes, and S of H, the output, represents your quiz score as a percentage. So what is 75? It's your quiz score. 75%. You scored 75%. Now most people are saying, wow, why did I study 81 hours to only get 75%? But this is just what we're given. So now we go through. If you study for 81 hours, okay, this has got the potential to be true. You will score 75% on the quiz. In fact, it looks exactly true. If you study for 0.75 hours, that's completely wrong. They've got the wrong value there. Your score as a percentage will be multiplied. There's no multiplication here. Your score as a percentage multiplied by 81. No multiplication here. This is function notation. This is it, A. Okay. It's only going to confuse us, these three wrong answers, if we didn't really understand what this function notation meant. Okay. So move on. Let's go ahead and change colors here. Since we can easily do that, we're going to go with green and promise to use this graph. So find h of 0. Now the 0 is input. It's an x value. So we come to where x is 0, and since x is going to stay 0, we go up or down until we hit the graph, which is right there. What's that? That's 1, 2. That's a negative 2 point something. Something. So then I'm looking, oh, the only thing, it must be a 6. Okay. We know it's negative. It's not to negative 3. There's negative 3. There's negative 3.2 would be down there. It can't be that. It's this right here. Okay. The other question's asking us h of x equals 0. So this 0 here is a y value. Y is 0 along the x-axis, actually. It seems kind of weird, but we don't go up or down, so we're stuck on the x-axis. This is where y is equal to 0. And there's two answers. We'll just see which one. So negative 1 point something, or 1, 2, 3, 4, about 4. It's not quite there. So then we look at our choices. Do we have a negative 1 point something? We don't, but we do have a 4. So that's the one we're going to choose. That's the best, closest answer. Okay, so this one gets you input output, and it's the hardest one to do because they're both 0. Both are starting at the origin 0, 0. One's going up or down, the other's going left or right, and they've got similar answers that if you get it backwards, your answer will be in one of the wrong categories, one of the wrong answers. So just be careful on this one. Know the difference between input, which is an x value, and output. So if we're given the input, we're looking for output. We're looking for a y value. If we're given output, which is the y value, then we are looking for an x value. Okay. We did number 4 on the regression video, so I'm not going to do it again. You could do it by hand, but number 5 we also did with the regression. That's the way I'm going to encourage you to do it, because that actually is going to be the most beneficial. You need to learn to do linear regression so that when we get to exponential and quadratic regression, it's just second nature. So I'm going to skip over those because I've shown you the method that I prefer and want you to use. I'll work with you individually if you want to see other methods, but other than that, that's where we're going to go. Okay. So this one we're asked to simplify. The first one, the parentheses can just come off because there's nothing in front and there's no exponent. So we can just rewrite it as, go with green, 2x squared minus 3x plus 5. This next step is what a number of students will miss, is that you have to distribute this negative to each of these terms. So it's negative 1 times each of these following terms, which is going to change the sign on each of them. Oftentimes they'll put the negative sign on the 5x squared, but they'll forget to change the other two. So what we're going to be doing is negative 5x squared plus 4x minus 7. And if we don't do this, that answer's here too. So, but we'll think we're right, but we're not. Go a little bit darker. So what we're doing is we're combining like terms. 2x squared, 5x squared. It's a positive 2, a negative 5, so that should give us a negative 3x squared. Okay, and we've got 3 choices now. We look at the x values, negative 3x and a positive 4x. So when we combine those, 3 minus 4, opposite signs, is going to give us 1. It's going to give us a positive 1x. And we can see now we've got it down to 2. It's either C or it's D. And then finally, plus 5 and minus 7. Those are our last combining. They're opposite signs, so we subtract. We know the answer is 2. 7 is larger and it's negative, so it's going to be a minus 2. -2, however you want to look at that. C is the correct answer. Okay. Very good. So let's, let me just, while we're here, 8, it's a composition of functions ones. We are actually not doing that anymore. This is out of the competency, so I should have taken it out, but I didn't. Sorry about that. I didn't see that that was one. Don't worry about doing 8. It won't be on the test. We talked about 7 using linear regression to get the average rate of change. I'm going to stick with that. Again, if you'd like to see it done in another way, I'd be happy to show you, but use the linear regression and the practice will do you good. These two, are they functions or not functions? And it says to use the vertical line test. So what is the vertical line test? Is we draw vertical lines. And let's see, my vertical lines are getting a little bit better than when I first started. Well, just when I said that. But each vertical line we could imagine that we can draw straight vertical lines. Each input has only one output. So this one, yes, it is a function. This one here, even though my vertical line may not be very good, I can easily see a vertical line will touch it in 2 places. That is called failing the vertical line test. We touched in 2 places. That means that this input has 2 outputs. So this is a no, it's not a function. Okay, watch it carefully. You'll have similar things on the test, and but you'll do just fine with it. Vertical line test, that's it. Okay, determine whether the following tables are functions or not. Okay, so what we're looking at is the inputs. So first of all, I've got 2, 3, 5. The inputs are all different. It's guaranteed to be a function. Each input has its own output. Okay, it's okay that it's repeated, that the 2 shares a 4 with the 5. Each input has only one output. For B, I've got repeated inputs here, 2 and 2. Now, if they have different outputs, which they do, 3 and 8, this is not allowed. This input has 2 different outputs, so this is not a function. Now, if the second one, the 2 was a 3, if it was 2, 3, 3, 17, and then 2, 3 again, it would be a function. So it is okay to have repeated inputs as long as they have the same output as they had the first time. Okay, I highlight that part because you might face it on the test. Let's just put it that way. Okay, and we're almost done because this one definitely, was done with the regression, and there's really no other way to do it. Okay, and I think we've just worked all the way through the practice test. Let's go backwards through it. There's some multiple choice ones I gave you. We worked through all of these multiple ways in the regression part as well. I think we did that, yes. And that's the main part we're going to focus on for the test. I know it's not everything, but I think it's the important things that keep us moving forward. So look over the practice test, work through it. Anything you don't understand, come to the, from the videos, ask me about again, and work through the Math AS homework problems on similar problems like these until you really understand each of these concepts. Okay, and then be sure before the test, get plenty of sleep, review a little, but sleep is one of the most important things you can do. There we go. So now we're ready to sign off. Have a great day. We'll see you later.